All right, guys, so we'll go ahead and start our 5-4 notes here. It's about dividing polynomials, and our learning target is I can divide polynomials using synthetic division and use synthetic division to determine factors and the remainder theorem of a polynomial. So you guys just did the warm-up, which was a good old long division problem, 272 divided by 21. And so just to review that, we're kind of looking at how many 21s go into 27. That would be 1. And then we take 1 times 21 to get 21. After that, we subtract to find the difference, which would be 6 in this case. We bring down the next number, which is a 2. And we kind of do the same thing, right? So now how many 21s go into 62? That would be almost 3, but not quite. So 2 and 2 21s is 42. And our last difference is 20. So our answer in this case would be 12 and 20 21st. Right? So just a review of how old school long division works. All right? Anybody have any questions before we get going? Okay, so one key thing when we're working through this first example, this is going to be the only one I show probably all year unless you specifically ask for it, by long division. We're going to learn to do this another way called synthetic division, but I will show you one by long division. Okay, so we kind of write it out the same way. We'd write x minus 7 outside the little box there, and the polynomial we're dividing into underneath. So 3x squared minus 29x plus 56. All right, now how do we do this? Okay, so we kind of do it the same way, we just did the last one. So we're going to look at how many x minus 7s go into that. Now, that's a little bit different, right? If I ask you how many x minus 7s go into 3x minus squared minus 29x, that's a little, we don't know that as well as how many 21s into 27, right? Here's how you basically do that. So you think about the kind of the lead term of each. So like 3x squared divided by x, and that would be just 3x. So that's how you know 3x goes here, okay? All right, now we do the same thing we did on regular long division. We have 3x times x minus 7, okay? So 3x times x is 3x squared. 3x times minus 7 is minus 21x. Now, the 3x squared thing, that should always happen, okay? You should always cancel that first term. So now we're subtracting. I would put parentheses around the binomial just to remind yourself visually that when we subtract a binomial, we're subtracting both terms. We distribute the negative is one way we say that, okay? So we got 3x squared minus 3x squared. That's going to cancel. That's always going to cancel. If not, you did it wrong. Then we got negative 29x plus 21x, right? Minus negative is plus. So that's negative 8x. And then we bring down the 56, so plus 56. All right, then we kind of do the same thing over again, right? So now we're looking at how many 3x's go into that. So to know the answer, we think negative 8x divided by 1x. That'd be minus 8. So then minus 8 goes here, and we distribute the negative 8. So negative 8 times x is negative 8x. See, we get that matchup again. And negative 8 times negative 7 is plus 56. So we get another matchup. And when we subtract, anything minus itself is 0, of course. So that's our remainder. So the answer to the question is that 3x squared minus 29x plus 56 divided by x minus 7 is 3x minus 8. So if you think about what that really means, right, how we could have derived that a different way, if I would have just told you to factor the quadratic, you would have had to do this process where we kind of think about, All right, what adds up to negative 29, multiplies to 56. We could split it up, do all that, and eventually we would get 3x minus 8 and 1x minus 7. So this is a kind of an alternative route here. Yes? How did what? Where did I get the minus 21? I'm just, I'm taking 3x times x minus 7. So 3x times minus 7 is minus 21x. Now, I will say that this particular way to do it, just regular traditional long division, is a little bit tougher. Okay, so because of that, we will focus most of our attention on synthetic division, okay, which is on the next side. So it says there's a step-by-step little thing there. Synthetic division simplifies the long division process for dividing a linear expression. So it's got to be by a linear expression. Step 1, it says write the coefficients, including zeros. You'll find out what that means in a later example, of the polynomial in standard form. So the polynomial we're dividing into on our next example is this cubic polynomial. Okay, so we'll go ahead and write its coefficients. 1 for x cubed, 2 for x squared, negative 5 for x, and negative 6 for x to the 0. Okay, now instead of making a box over the top, we kind of make our box upside down. So now we'll go down, leave a little space for a row underneath, and like that. Okay. All right, now what goes outside the box? So now we're looking at step 2. It says for the divisor, solve for the zeros of the factor. Okay, so we don't put, like, you know, based on what I just did there, you might think like something like this goes outside. That would be wrong. Okay, what we do instead is we think about, you know, what zeros go with this factor, right? So that would just be x equals negative 1, right? So negative 1 is what goes outside. You can see how that would be easy to forget. So you'll have to remember these things through repeated practice. Now, focus on the process here. This is a very procedural thing, and I think you'll get it as we do a few examples, okay? First thing you always do is you bring down the lead coefficient. So that goes there, okay? That's the first part of our answer, which we'll talk about in a second, okay? Then we take negative 1 times 1, okay? Negative 1 times 1 is what goes underneath the 2. That would be negative 1. One thing I see people do wrong a lot on this is so we're used to subtracting with long division, right? So they'll say 2 minus negative 1 is 3. That's true, but we don't subtract here. We add those two. So 2 plus negative 1 is just 1. Okay, so 1 comes next underneath the 2 and the negative 1. You might want to put a little plus sign there to remind yourself. All right, now we multiply again. Negative 1 times 1, it goes under the negative 5, so that'd be negative 1. Add them again, and we get negative 6 underneath those two. All right, anybody know what's going to go under the next negative 6? Not negative 1. That's all right, though. 6, right? So you take negative 1 times negative 6 to get 6, and then we can add those up, and we get 0. Now, what's all this mean? Okay, so let's focus on this little sidebar here, specifically step 5. Write your polynomial answer. So the degree of the answer is always 1 less. I would maybe highlight that. 1 less than the degree of what we divided into. The last number is the remainder, okay? So what we were dividing into in this case was a cubic. So that means my first term is a second degree term, right? So this 1 right here is my lead coefficient for x squared, all right? So then it's 1x squared plus 1x minus 6. The last number is my remainder, okay? So I'm going to box this in and just note that the remainder is 0. Yes? So we don't multiply the top row at all by -1. We multiply that middle row by, or sorry, we multiply the bottom row by -1 to get the middle row. So let me just go over to the board and kind of point it out. Okay, so we start by bringing down the lead coefficient, right? And then we start to multiply. So -1 times 1 gave me that, right? Now I'm adding, okay? So now I get the 1 in the middle. Then I repeat, -1 times 1 is -1. And you'll forget some of this stuff, right? Everybody's confused right now. You kind of get the procedure as we go, okay? And then we add again to get -6. Multiply to get +6, okay? So you just got to practice it a few times. Once you get good at it, man, you can do that in about 5 seconds. Yes. Right, just like we would to get the, so the question was there, why do we get the -1 outside the box? And yeah, just like we would if we were using the zero product property there to find our zeros. Yeah, yep. All right, all good questions. So you guys, let's kind of set up the first part and have you try to take it from there, you and your partner. So there's one trap I don't want you to fall into, which is when we write out our coefficients. So 1's going to come first. If I told you -57 doesn't come next,